Okay, so if a parallelogram has a base of 10 centimeters and a trapezium of the same area and height has a base of 14 centimeters, find x, the length of the other parallel side of the trapezium. Okay, so I'm looking for this side here, and I'm told that my trapezium, one side of the parallel side is 14 centimeter. I'm told that this area is equal to this area of my parallelogram, and I'm given that the base of my parallelogram is 10 centimeters, and I'm told that the height is the same in both of them. Okay, so the first thing I need to do is I need to get the area of my parallelogram. So my area of my parallelogram is equal to base multiplied by perpendicular height. Okay, so my base here is 10, and my height, we don't know it, it's h. So we say that my area of my parallelogram is going to be 10h. My area of my trapezium then is half my x plus my 14 by my height. Okay, we still don't know what the height is, but we know that they're the exact same. So when I write this out, I'll say that my area of trapezium is equal to half x plus 14h. I was told in my question that the area of the parallelogram is equal to the area of the trapezium. So I say 10h is equal to half x plus 14h. What I'm going to do now is I'm just going to divide across by h, okay? And I'm left then with 10 is equal to half x plus 14. Right, I want to get rid of my fraction, so I multiply across by 2. So I have, 1 second, sorry now. So I have 10 times 2 gives me 20, and that's equal to x plus 14, okay? And then I bring everything to one side, so I have 20 minus 14 is equal to x, so I get x is equal to 6. So the other parallel side was equal to 6 centimeters. Now I'm just going to look at polygons, okay? So a polygon is a plane, okay? So it's a 2D shape with straight edges. Regular polygons are symmetrical, okay, with a base triangle repeated in polygons with more than 4 sides. Okay, so the interior angles of regular polygons are, so for a triangle it's 60, for equilateral it's 90, for a pentagon 5-sided shape is 180 degrees, for a hexagon 6-sided shape is 120 degrees, and for an heptagon for that 7-sided shape it is 128.6 degrees. Right, here I have a question about polygon, okay? Right, so the area of the regular pentagon shown here is 600 centimeters squared, right? Pentagon, it's a polygon, it's a 5-sided shape. And I'm asked to calculate the length of one side x of the pentagon. Okay, so I need to find, I've drawn out my pentagon here, so my 5-sided shape, and I'm looking for one of the lengths here, x, okay? And I was given that the area of this entire shape was 600 centimeters. And I know a full rotation in a circle has to add up to be 360 degrees. So I'll be able to find out what would one angle in my triangle have to be. Okay, so the total angle at the centre of the pentagon is 360. So I go 360 divided by 5 because there's 5 different triangles in a pentagon. And that's equal to 72 degrees. So I'm after finding out that this angle here is 72 degrees. Each triangle is congruent, okay, so if you look back at the previous definition that I just explained, okay, so all the triangles have to be the exact same in a pentagon, and they have equal base angles, okay, right, so these two angles have to be the exact same, and we already know that this angle here is 72. So I'm able to go 180, take away my 72, and divide it by 2 because there's 2 of them, and we have that's equal to 54 degrees. Each triangle, I was told, has an area of, okay, so 600 divided by 5, because the total shape was 600 centimeters squared, and because there's 5 different triangles, I just divide by 5. So my area of one triangle is 120 centimeters squared. Now I'm just after drawing out my triangle here. Okay, so this here is one of my triangles in my pentagon. Okay, so the length here is x. My base angles were 54, and this angle up here was 72. Okay, right, so I'm looking for this here, and I have all of the information. I already know what the area of this shape is, but I don't know what my height is. Okay, so what I'm going to do is I have this is x, and I'm just going to split it into this. So this is x over 2, and this is x over 2. Right, I need to use my trig ratios to find out what is this actually going to be equal to. Okay, so I use my 54 degrees. Okay, so I'm after making a right angle triangle, and that's why I'm using my trig ratios. So this here is my opposite, this here is my adjacent, so I have to use tan. These are all the rules laid out here if we've forgotten them, but they are in our log tables. So we have then, okay, so tan 54 degrees is equal to my opposite, which is h, over my adjacent, which is x over 2. Okay, so then I have h is equal to, so I multiply across by x over 2. So I have, this is what my height is now equal to. Okay, right, so the area of the triangle is equal to half the base by the height. So I now have my base and I have my height. So I go half by my base is x, my full base, and that's what I'm looking for, by my height is x over 2 tan 54 degrees. And I was told, okay, that the full area was 600, so I divided by 5. So I get the area of one triangle is just 120. Then what I do is I multiply, okay, so x by x, so 1 by x gives me x squared, and then 2 by 2 gives me 4. Tan 54 degrees is equal to 120 centimeters squared. So I have x squared tan 54 degrees is equal to 120 by 4, because I'm just getting rid of this fraction here. And I have x squared tan 54 is equal to 480. So I now have x squared is equal to 480. I've divided across by tan 54. And I get x then on its own is equal to the square root of that. So I get the square root of that then, and my answer, when I put that into my calculator, I get 18.7. And that's where that one comes from. Okay, so the first question that we were dealing with from your book says that a parallelogram is drawn inside a rectangle as shown. Using the measurements given, the fraction in terms of a of the rectangle's area that is taken up by the parallelogram, and the value of A required so that the area of the parallelogram is equal to 4/5 of the area of the rectangle. So the first thing I need to do, okay, so we can see from the diagram that the darker shade is actually the parallelogram, okay, and the outside of that is just my rectangle. So I know that the formula for the area of a rectangle is equal to length multiplied by breadth, okay. Right, so my full length across in my diagram is ax plus 2x, okay, so that's the full length, so that's ax plus 2x, and my width is 2x, so I multiply those out to get my area. So I get ax times 2x gives me 2ax squared, and I have 2x times 2x gives me 4x squared. Then I need to get the area of my parallelogram. So the area of parallelogram is base by the height. Okay, so my base of my parallelogram this time is just ax, and my perpendicular height is 2x. When I multiply these out, I get 2ax squared. I was asked, the first part of this question was to ask me to find the fraction in terms of A of the rectangle's area that is taken up by the parallelogram. So the parallelogram over my rectangle, so my parallelogram is 2ax, over my rectangle is 2ax squared plus 4x squared. And then I factorised the bottom line out here. So I took out my 2x squared, and I was left with a plus 2, and my line up here stays the same, it's 2ax squared. Then what I need to do is I need to divide across by 2, okay, so that cancels with that 2, and this x squared cancels with that x squared, and I'm just left with a over a plus 2. The second part of this question said that the value of a required so that the area of the parallelogram is equal to 4/5 of the area of the rectangle. So I'm looking for the value of a here, right? This is my area of my parallelogram, okay? So it's 2ax squared, and we're told we want to find out when it's equal to 4/5 of the area of the rectangle. So 4/5, my area of my rectangle is 2a squared plus 4x squared. Then what I need to do is I'm just going to multiply across by 5, and I'm going to have, so 5 times 2ax squared will give me 10ax squared, and that's equal to 4 times 2ax squared plus 4x squared. Then I multiply my 4 into my bracket, and I'm left with 8ax squared, and my 4 times 4x squared gives me 16x squared. I bring everything now to one side because I need to solve for my value for a. So I'll have 10ax squared minus 8ax squared when I bring this over, and then bring this over becomes minus 16x squared, and that's equal to 0. So when I take these away from each other, I'm left with 2ax squared, and here I have minus 16x squared, and that's equal to 0. Right, so I'm going to factorise, I'm going to take out my 2, my highest common factor in that is 2, and I can also take out my x squared. And when I do that, I'm just left with a minus 8, and that's equal to 0. So I have a minus 8 is equal to 0. So the value that a needs to be for the parallelogram to be 4/5 of the area of the rectangle is a has to be 8. Question 2 then asked me, so it said, calculate in terms of x the area of the darker section of the rectangle and the area of the lighter section of the rectangle and the ratio of these two areas. So from the diagram we can see that the area of the darker is actually going to be the area of the two parallelograms, and the lighter section is just going to be the rectangle, take away my two parallelograms. Okay, so I have then the area of the dark parallelogram. So my area of parallelogram is the base by the perpendicular height. Okay, my diagram isn't great here, but if you look at your book you'll see it better. Okay, so I'm just going to look at my first parallelogram. So my base by my height is going to be my 2x, and then my perpendicular height is 3x. Okay, and then so that's equal to 6x squared, and then the area of the other parallelogram is going to be 2x by 2x, and that gives me 4x squared. So my area of my parallelograms, my darker section, is 10x squared. My area of my lighter section is everything outside here. Okay, so it's the area of the rectangle take away my area of my parallelograms. So my area of rectangle is my length by my breadth. So my length here is 5x, and my breadth here is x plus 2x, which gives me 3x. So 5x times 3x gives me 15x squared. Take away my 10x squared, and that gives me 5x squared. The last part of this question, it wants me to get the ratios of these areas. So I have dark to light. So the dark part of this diagram took up 10x squared, that was my parallelogram, and the light part was everything else, and that was 5x squared, and that's divided into the ratio 2 is to 1. The next part of question 3 says, if the height of the triangle is 5 centimeters less than the length of its base, and if the area of the triangle is 52 centimeters squared, find the length of the base and also the height of the triangle. Okay, right, so I'm trying to find the length of my base, the height of my triangle. Okay, and I'm given enough information, I'm told the area of this shape. Okay, so I always draw out a diagram in area to try help me visualize what I'm actually looking for. Okay, right, I was told in this question that the height of the triangle is 5 centimeters less than the length of its base. Right, I don't know what its base is, but I'm just going to call it x. Okay, and if my height is 5 centimeters less than it, I just go x take away 5. Okay, and if you want to think about that logically, if your base was 10, your height would have to be 5. Okay, because you'd have to have it's 5 less than the base. So what I do then is my area is equal to half the base by the perpendicular height, and I know that my area in this particular question is 52 centimeters squared. So that's equal to half my base in this triangle is x multiplied by my perpendicular height, we said was x minus 5. Right, then I just have to multiply. Okay, so x times 1 gives me x over 2, and I need to multiply that by x minus 5. Okay, so I'm just going to multiply out the brackets first, like so, and I'll have x squared minus 5x over 2, and that's equal to 52 centimeters squared. Now I'm going to get rid of my fraction here. I'm going to multiply across by 2. So I'll have x squared minus 5x is equal to 104 centimeters squared. So I'll have x squared minus 5x minus 104 is equal to 0. This is the quadratic equation now which I need to solve. Okay, so I have, when I solve this, I get x minus 13, x plus 8, and that's equal to 0. So I say x is equal to 13 and x is equal to minus 8. Right, we cannot accept minus 8 because we're dealing with the length of a triangle, and we cannot have a negative length of a triangle. So we say that x is equal to 13. So my base has to be 13, and my height was going to be 5 centimeters less than my base. So it's 13 take away 5, which gives me 8 centimeters. Okay, question 4. Now in this particular one, it says, given that the hypotenuse of a right angle triangle is 41 centimeters and the sum of the other two sides of the triangle is 49, find the length of these two sides. Right, so I'm told that my longest side has to be 41, right, and this plus this has to give me 49 when I add them up, okay, because I was told the sum of them. Right, so I said a plus b is equal to 49. Or I could say that a plus my question 9 is equal to 49. So my question mark is equal to 49 minus a. So what way I've done it is, this is 41. This I'm just going to call it a. And this, because these two have to add up to give me 49, I have to say 49 take away my a, and that will give me this side here. Because we're dealing with a right angle triangle and we're looking for a missing side, I'm going to use my Pythagoras theorem. So it's a squared plus b squared is equal to c squared. Right, so I have a squared plus, I put in for my b 49 minus a to be squared, and that's equal to my c in this case is 41. Okay, right, so I have a squared. When I square this out, so it means to be multiplied by itself, I get 2,401 minus 98a plus a squared, and that's equal to 1,681. Right, I'm going to bring everything to one side. So a squared plus a squared gives me 2a squared. I have minus 98a. I'm going to bring this over and I get plus 720 is equal to 0. Right, I want to make this quadratic as easy as possible for me to solve. So I divide by the common factor, which is 2. And I'm left with a squared minus 49a plus 360. And now I need to solve this quadratic, and when I solve that quadratic I have a minus 40, a minus 9 is equal to 0, so I get a is equal to 40 and a is equal to 9, so this is what the length of the other two sides are. And that's question 4 solved. Okay, so for question 5, what it says is that a rectangular wooden frame, so we know the shape we're dealing with is a rectangle, is built to lay a concrete foundation for a patio. To support the frame while the concrete is being poured, steel cables are fixed diagonally across the rectangle. Okay, so it's looking something like this. Okay, so they're fixed diagonally across the diagonals to help support it. And we're told that they protrude, okay, so that they're longer than the wooden frame by 50 centimeters. Okay, if the perimeter of the frame, because the perimeter of my rectangle is 14 meters, okay, now we need to look really closely here. They're after switching between centimeters and meters, okay, so we need to only have the one unit, and the length of the frame is 1 meter longer than its width. Find the length of the steel cable required. Okay, right, so I'm not given any dimensions, okay, but I'm just being told that the length of the frame is 1 meter longer than the length of its width. Okay, so my length is longer than my width by 1 centimeter, so I'm just going to say that my width is x, and then my length of my frame here is going to be x plus 1. It's 1 centimeters longer, or 1 meter longer. Then what I have here is this is going out by 50 centimeters in all directions, like so. Okay, so the information that I have at the moment is I have that my perimeter is 14. The length of the frame is 1 meter longer than its width, okay, and I need to find the length of the steel cable. Okay, so this is what I'm trying to find out, my length of my steel cable going the whole way across and whole way across like this. Okay, so my perimeter, then I add up all the sides and I know this is equal to 14, so I say x plus 1 plus x plus 1, okay, and I get 4x plus 2, and I let that equal to 14 meters. So I have 4x is equal to 14, but over my 2 becomes minus 2, so I have 4x is equal to 12, and I go x is equal to 3 then on its own. Right, so I'm after finding that my width here is 3, and my length here is 4, because it was 1 centimeter more. Right, I'm looking for my steel cable. My steel cable is my diagonal. That's what I'm looking for, okay? And what I basically have is if you look closely, I have 2 right angle triangles, okay, made in my square. So what I'm going to say is this part here is 4, and my width here is 3, and I don't know what my diagonal is. I'm going to ignore the fact that it protrudes out for the moment by 50 centimeters, and I'm going to look at that in a few moments, right? But what I'm looking for a missing side, and I have a right angle, so I must use Pythagoras' theorem. So I go, my diagonal to be squared is equal to 4 squared plus 3 squared. Okay, so d squared is equal to 4 to be squared is 16 plus 9. And I have d squared is equal to 25. So my diagonal here has to be 5. Right, so we're just after figuring out that from here to here is 5. That means from here to here is 5. So I definitely have 10 meters worth of steel cable being used. But I haven't looked at how much this is taken up. Okay, so I'm going to look at the total here. So what I do is my steel cable is 2 by 5 plus 4 multiplied by, I told you at the start that this is in centimeters, I need to put it into meters, so from centimeters to meters I need to divide by 100, so I get 0.5, and when I put all of this into my calculator I get that the steel cable is actually 12 meters.